All right. We're going to do for 4.6 is we are going to look at graphing the other 4 trig functions. All right. Tangent, cotangent. We're going to start with, I'm going to flip over to third page. We're going to start with secant and cosecant. And what we have here is, it says, since secant and cosecant are the same as the reciprocals, they have the same period. Also note that there are several real numbers which are not defined by these functions. Okay? And here's what the important part is. When graphing the cosecant and the secant, it's helpful to graph the corresponding sine graph or cosine graph. The vertical asymptotes of the cosecant graph is where you have x-intercepts of the sine graph. Relative maximum points are the relative minimum points of the cosecant, relative minimum points of the sine, so on and so forth. A similar relationship between secant and cosecant is, and it's corresponding. So let's go ahead. This is just information. You guys can read it. Let's go ahead and let's graph these functions here. So let's start with secant. Okay, we're going to do y equals secant of x.
Third page?
We're on the second page of the graph. We were just on the third page of the notes. Yeah, I'm sorry, we're on the second page.
I don't know if you already have every teacher I give one of these to, so they already have it.
This is the first page. We had sine and cosine. Second page we're going to do secant at the top. Okay? Now, secant, so let's label this. Let's put the same.
Is it secant of x or secant of theta?
It doesn't matter. Secant theta, secant x, it's the same thing. They're variables. And since I've got these labeled x and y, I'm going to go ahead and just do x here. It doesn't matter. If you want me to be the same as the others, we'll do theta. And I don't know if I changed the grid yesterday. I did. Yeah, I did here. Theta, whichever, it doesn't matter. All right, so we did every fourth one. That was pi over 2, pi, 3 pi over 2, and 2 pi. And then we went up 5 was 1. Let's go ahead and just do both these graphs on this paper. Go ahead and label your x and y axis. And this one's going to be cosecant. All right, for secant, it's a reciprocal of which trig function? The cosine. So what we're going to do is I am going to graph the cosine on here, but I'm going to graph it as a dotted line. Cosine starts where? It starts at the, cosine makes your u. So it starts at 1, over here at 2 pi, it ends at 1, halfway between is our negative 1. Then halfway between those two, we have our x-intercepts. I'm just graphing it as a dotted line. I'm going to go ahead and do the second period over here. When you go to graph these secant and cosecant in your homework, this is what you want to do. You want to graph the corresponding sine or cosine graph as a dotted line. And now, at those zeros, when I take the reciprocal of 0, what do I get? We get 1 over 0, which is undefined. So we have an asymptote at all these x-intercepts.
Yes.
So you guys can see that. All right, now, up here at 1, what's the reciprocal of 1? 1. What's the reciprocal of negative 1? Negative 1. So these maximum midpoints of our cosine function, they don't change. But remember at pi over 4, we had square root of 2 over 2. What's a reciprocal? Take square root of 2 over 2 and change it, do its reciprocal, which is 2 over square root 2. And someone give me the decimal equivalent to that. So it's bigger than 1. So at pi over 4, which is right here, it's larger than 1. So what happens is, in between these asymptotes, do you see u's? This is an upside down u. What happens is, we take the reciprocal. Those u's flip upside down. And then what you can do is you can just erase that line in there. And there's our cosecant graph. That's pretty cool. So the domain of our secant is no longer all reals. This one has a domain of all reals except x can't be pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. What's its range?
Oh, it's all real numbers except like between 1 and -1.
Yeah, it's all real numbers except for all numbers between 1 and -1. All right, questions there. Cosecant. Well, for the cosecant, we're going to graph which function?
Sine.
The sine. So sine starts at 0, at pi at 0, 2 pi at 0. Pi over 2, it's at 1. 3 pi over 2 is at -1. So this is just the sine function, dotted in. Okay, now where are my asymptotes? At, yep, at these x-intercepts. 2 pi, negative 2 pi, negative pi, 0, pi, 2 pi. And then what happens to the curve in between? They flip upside down. And if you remember, graphs approach asymptotes. Then you can erase. Questions there? Go to the very last page of your notes, and we're going to graph this function first. The very last, we're going to do example 3 first. Emmy, Boots. All right, let's look at example 3. Which trig function are we going to graph? Well, this is 2 cosecant, but we're going to start by graphing 2 sine of x plus pi over 2. Okay, this has a phase shift. So if we do the phase shift, that's x plus pi over 2. Sine starts at 0. Sine ends at 2 pi. So first, we're going to graph the sine function. So it's going to begin where? Solve for x. So I'm going to, so it's going to begin at negative pi over 2, and it's going to end at 3 pi over 2. Because 2 minus 1/2 is 1.5. 1.5 is 3 pi over 2. This has an amplitude of what? 2. It has a period of what? Well, there's 1 in front of the x, so it just has a period of 2 pi. So pi over 2, there's 1, 2, 3, 4. There's our 5 important points. This one's easy enough. Pi. So then sine is the S shape that starts at 2 pi, ends at 3 pi over 2. This is negative. Goes up to 2, down to 2. There's our dotted line, our dotted sine graph. So there's the sine graph graphed. And now to get the cosecant, what do? Asymptotes are at our x-intercepts. And then we flip the u's.